Wait a moment. Okay. So so I'm going to present the first problem. Oh, so like there's somebody who wants to present Kara. You raised your hand. Do you want to present?
Yeah.
Okay, we can go ahead. Please present your solution.
The formula for the angle in a regular polygon is like the exterior angle is 360 divided by n. So the interior would just be 180 minus that. So this is the formula. And then you're given that the difference between this and the you're given that the difference between this and the like with n plus 1 is 5, so like you can make this equation and then you know that the angle with the larger polygon will be bigger, so you have to add 5 here, and then you can get the equation that 5 minus 360 over n equals minus 360 n plus, wait, no, wait. Yeah, so, and then you can just basically like test values. So you have like 360 over n is equal to 360 over n plus 1 and then plus 5. So then you start testing values and you start from n equals 3 because if you have n equals 2, you don't have a polygon. So from n equals 3, you get that it's, so you can start listing the angles. And so for 3, it's 120. And then no, I mean yeah, 120. For 4, it's 90. For 5, it's 72. For 6, it's 60. For 7, for 7, it's a fraction, and that can't even be possibly the answer. So we just move on to 8. 8 is going to be 45, and 9 is 40. So you see that n equals 8 works, so that's our answer. And you can like, once you have this equation, you could always just cross multiply, but that would be a lot more complicated.
So Amar,
Did
are you
somebody
done? Oh, okay. Yeah,
did
go ahead.
somebody raise a hand? I accidentally clicked. Yeah. Stefan. Can you like what did you want to say?
So we could do this instead of like guess and check, we could do this another way.
Yes, I agree. You could like turn it into a quadratic equation and solve that instead. Can people start moving things around on the whiteboard? Um, so like that's a very good idea. So after this, I'm going to present another method, and instead of using exterior angles, such as which they used in this example in the formula, I'll be using a different formula for this. So I'll be starting to the right. So so the formula that I will be using is that if there's a polygon with x sides, then the interior angle is equal to x minus 2 times 180 degrees over x. And so interior angle of the bigger one, or the one with x plus 1 sides, is x plus 1 minus 2 over x plus 1 times 180 degrees, which is equal to x minus 1 over x plus 1 times 180 degrees. The one for the smaller one is x minus 2 over x times 180 degrees. And then now we know that the angle for the bigger one is going to be larger. So if we add 5 to this, we get that this is equal to x minus 1 over x plus 1 times 180 degrees. So now we can divide by 5 on both sides to get that x minus 1 over x plus 1 times 36 is equal to 1 plus x minus 2 over x times 36. And after this, we can multiply by x times x plus 1 on both sides. So we get x minus 1 times 36 times x equals x times x plus 1 plus x plus 1 times x minus 2 times 36. And after simplifying this polynomial and canceling out the terms, we should get that x times x plus 1, or instead x squared plus x minus 72 equals 0 in standard form. So we can change that to x squared plus x equals 72. Or factor that into x times x plus 1 equals 72. Now, this equation you could solve using the quadratic formula or some other method or other ways, but I prefer a method that is more easier to do. Can people not write on the board? So this method is easier to do since, like, like what it can people. Okay, thank you. So this method is easy.
Oh, Edward, you need to turn eyes on me because William Lu just accidentally pressed eyes on him. Yeah. Yeah, that would be great. Thank you. Yeah.
Can okay, wait. Okay, so now like this method is like more like fast, and we realize that the left side of equation says that if a number times that number plus 1, it's going to be the right side, which is 72. Now conveniently we know that 72 easily factors into 8 times 9, so x must be 8 because x plus 1 will fit directly into 9. Cabra, you raised your hand. Did you have to say anything? Did
I have
you?
a question. So,
Mm-hmm.
isn't this method like a lot more complicated, and then you end up like basically doing guess and check at the end?
Yes, and so like I basically used a different formula, but if you like prefer, I if you like prefer the easier to know formula, or because like that formula is you can use that formula and it's like a little faster in some ways, so you could use both methods here. So it's okay.
Okay.
Is there any other questions? If there's no questions, then uh if there's no questions, then we can move on to the second one. If there's anyone that wants to present for the second one, yes. Is there anyone else?
Who
Okay.
who wants to present the second one? Oh, so Omar. Okay. Yeah, go ahead, please. So Omar, when you present your solutions, please click the eyes on me, okay? So everyone can follow you. Oh, Jin, you want to? Oh, okay. Oh, I think yeah, Omar just presented his method. Probably we need to give a chance to the other like two students first. Later, Omar can add something to their solutions. Okay. So Jinyu, your turn. Yeah, this time.
So basically, like it says it's a isosceles right triangle, and this is C. So we'll just put like A over here and B over here. So then like it said D and E like trisects AB, so we'll just put D here and E here. And the problem said that AC is 8. Since this is an isosceles triangle, then BC is 8. So AB is 8 square root 2. So that means AE equals BD equals DE equals like 8 over 3 root 2, because like BD, DE, and AE like trisects AB. So then like we put altitude like here, like it's, and then we put like, for example, F.
Can you stop for a moment because like somebody raised their hand. Is there like a question?
Wait, so don't D and E have to be switched because it says AD equals D equals EB?
What?
So uh they were saying that like D and E should be switched since the problem specifically stated that AD equals ED.
Okay.
Like you can just do that. It's not like a big problem, but you should like make sure your lettering is correct.
Oh, okay. So basically, if I draw this correctly, EF is supposed to be equal to FD because it's the altitude and it's an isosceles triangle. So basically, then like FD will be 4. FD is equal to 4 over 3 root 2. So basically, we can get CF in triangle ACF. CF is equal to the square root of 8 squared minus 4 root 2 squared. So CF will be 4 root 2. So CF is 4 root 2. And since we know FD, then we can know CD. And CD is equal to CE because it trisects the isosceles triangle. So yeah. Yeah. So CD equals CE equals square square root of 4 root 2 squared, and then plus 4 over 3 root 2 squared. And then you get that CE is equal to CE equals to square root of 320 over no wait. So square root 32 plus 16 over 9 times 2, which is basically 32, and then over 9, and then you get that square root 288 plus 32 over 9. So then you get square root 312 over 9. Then you get that it's equal to 312 root over 3. And then you square that, it's basically 312 over 9. So the answer will be 3, 2, 1.
Okay, so Zheng Yo, that's a good solution. At the end, like the logic is right, but at the end, the answer is wrong because I think over here, like over here for this step, like the 288 plus
Yeah,
32.
I think the answer is 329.
Yeah, the answer is 329 because that would be 320 over 3 then. So yeah, but your logic was right though, just saying. Okay, and now Kyle, do you want to share your solution now?
Yeah.
Okay, let's see it.
I drew triangle ABC as I gotta stop.
Kyle,
drew triangle.
Kyle, you need to turn the eyes on you, okay? So everyone can follow you. Yeah, thank you.
So I drew an isosceles triangle as the first step. How do I use this thing properly? And then I drew the diagonals. As accordingly. So AD equals DE equals EB, and they gave that AC equals 8. So that therefore AB equals 8 times root 2. So I figured out AD equals 8 root 2 over 3. Can someone help me? Then I drew I dropped perpendicular from from D to AC and named the new point P. So I figured out that DP is equal to A over 3. And then since DP equals A over 3, AP also equals A over 3. So I gotta stop doing that. So therefore PC PC equals 8 minus A over 3 equals 16 over 3. From there, I used the Pythagorean theorem to figure out that DC was equal to since DP equals 8 over 3 and PC equals 16 over 3, I squared DP and I used the Pythagorean theorem to get that no, DC equals root 320 over 3. And then after that, I had to figure out what DC times EC is. So since DC equals EC, I just squared this number right here and got, nope, not what I wanted to do. 320 over 9. Therefore, my answer was 329.
Okay, so Kyle, that's a good solution as well. Now, before we move on, does anyone have any questions about the two solutions presented? Um, that's a no, I guess. Now, does anyone have any other solutions they would like to present that are different from these two? Also a no, I guess. Okay, so now I'll just present the official solution. So the official solution is about the idea of coordinate geometry, or basically just turning the graph into a coordinate plane and then setting coordinates to the points. And here, here our graph is like this. These are straight lines. And then that. So that's our triangle ABC. And then
Edward, Yichen, turn the eyes on yourself, okay?
okay, yeah, eyes
Okay.
on me, guys. Okay, so then we have D and E. Yeah, I haven't even labeled these yet. That's C, A, and B. Yeah, that's a right angle, and that's D. That's E. Okay, so now our next step is to determine which points we should set as the origin. Now the origin is usually now we usually set the origin as some point that we can like compute the other coordinates very well with. So here it's the best to set C as the origin because because if that's a right angle, then that means that CB would basically be the x-axis and CA is the y-axis. So we can let C be 0, 0. Oh, that's 0. Okay, that's a 0 by the way. And then we can let B be 8, 0. That's A is 0, 8 then. And then because we know that D and E are the trisection points of them of AB, then we can compute the coordinates of that was an accident. Then we can what is this? Then we can compute the coordinates of D and E. And then D here would be 1/3 of the way from A to B. So then D would just be 8/3 and 16/3. And then here, because we know that CD is equal, these two sides are equal because, well, triangle CAD is congruent to triangle CBE. Oh, Cabra, what's your question?
This is kind of similar to the one Kyle said, right? Like where you drop the
Yeah.
perpendicular.
Yeah, but like the coordinates like make it like more easier to like see. So here, because we know that these two triangles, like I said, yeah, these two triangles are congruent, then we already know that CD equals CE. So then we can use Pythagoreans to compute the length of CD squared, and CD squared is just 8/3 squared plus 16/3 squared. And then that's our answer because CD equals CE. So CD times C would just be CD squared. And yeah, that's equal to 320 over 9. Indeed. Then 329 is the final answer. Okay, now, does anyone have any questions about this problem and its three solutions that were mentioned? Okay. If that's a no, then I think now we should move on to a third problem, and I'll leave it to Edward.
Okay. Thank you to Yichen for that amazing solution. Next I'll be talking about the third problem. Does anybody have a solution? Yes. Is there I see Cabra has a solution. Is there anybody else that has a solution? Uh okay, Cabra, you can present your solution.
Okay. Wait, let me make all eyes. Okay. So basically, like I first thought like if you put like ones, if you just put like keep on like having ones for then it'll take like until 13 ones to make it like a multiple like the sum of consecutive ones 13. So then I thought like what if we put twos? If you keep putting twos, then you can never get a sum of 13 because the sum will be even and then and then you want it to be 13, but there's a problem because it says that um it says that it has to be like it can't be more than 60. So wait, let me just check the problem. Yeah, it cannot be more than 60, so you have to stop. Like you can do 32s, and this does not have, if you have 32s, then this does not, like this works. I mean, like this like doesn't work. So basically, now we know that the answer has to be greater than equal to 31. So now anything with 31 has to work because you will have the sub. So like, if you have any number like it has to work because you can't keep on, the only way to not have it work is to keep on having consecutive like you can have some, yeah, like you can have, if you, let's say you have some number of ones and some number of twos, whatever you have, like let's say you have 1 1, then then and like 32s and 1 1. I mean, this doesn't work, but like 32s and like 32s and 2 1s, then like you can always just take 1 1 and like 6 2s and it'll work. So the answer is just 31. I think that's, wait, is the answer 31?
That's a good method, but I think there was a mistake because you can't just assume that that is the only method you can place the numbers. And so the correct answer is greater than 31, but it is not 31 because there are other methods that you can order the numbers in order to have more than 31. So, does anybody have questions so far? If not, I will move on to my solution for this problem. Wait. So first, is there any questions? Okay, so next I'm gonna present my solution to the problem. So I'm going to present a solution that's like a little more complete and so first we want to make sure that in order to maximize the we should minimize the number of days and guarantee that there's a number of consecutive days that the hours sum to 13. We're going to need something that wait. Somebody asked when we will get our scores. I think we'll get our scores after the class or after Nada's presentation, or you can check the answers by yourself and add up your score. So like as I've said, we need to find a way to like know like the sum of all the days without having to add them up. And so I'm going to create a new variable denoted by P of n, and this is going to equal to the sum of the first n days. For example, if I have the day hours per day like 1, 1, 1, 2, or something like that. Then the P of 3 is equal to these added together, which is 3. So then I'll move on to make a claim that if there's a P of n and a P of m with n greater than m, and that Pn equals Pm plus 13, then this condition is satisfied and a certain number of days, consecutive days, sum up to 13 hours. So I'm going to show this by I'm going to assume that the days are D1, D2, D3, and so on. And so like Pn is going to equal to D1 plus D2 plus dot 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 Dm plus Dm plus 1 plus dot 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 Pn Dn. We can do this because we know that n is greater than m, and so we don't have to like say that the dn is before dm. So next, Pm is equal to d1 plus d2 plus all the way to dm, and if we subtract these, we get all of these terms cancel out, and we're left with dm plus 1 plus all the way to dn is equal to something. Now, this condition here tells us that Pn minus Pm equals 13. So this has to equal 13. And that means that the consecutive days from m plus 1 to n have a sum or total hours of 13. So that satisfies our condition. Also notice that if we have a certain number of consecutive days, x to y, we can find those corresponding p's that satisfy this condition. So what I proved by doing this is that if I have the condition satisfied, then there needs to be two such p of n and p of m. And if there's such Pn and Pm, then the condition is satisfied. So the condition is satisfied if and only if we have these two. So now in order to optimize our number of days, while still guaranteeing that the condition is satisfied, we can first see how many days we can get before we have to have 2p of something that satisfy this condition. So in order to satisfy this condition, which is that p of n equals p of m plus 13, we see that 2p of somethings have to differ by 13. There has to be a difference of 13 between them. In order to make this easier to count, we can split all the numbers into groups mod 13. So we have like 1, 14, 27, 40, 53, which have remainder 1 while being divided by 13. We have 2, 15, 28, 41, 54, which is remainder 2 mod 13. Can people not randomly write on the board? Thank you. So in the next list will be 3, 16, 29, 42, 55, and so on. Now at one point, the list where did that come from? Okay, so at one point the lists will have will have 4 numbers in them. So you need to like notice that, because like some point it will the 50s will run out. So like for example, 13, 26, 39, and 40, and oops, not 40, 52 is one such example. So after this, if we want to guarantee that P of M does not exist, the P of N equals P of N plus 13, we can now easily see that in any such group there cannot be two P's that are consecutive, like 1 and 14, or like 28 and 41. They have to be at least one apart, like 27 or 53, or 16 or 55, or not in the same group. So the maximum number of P's we can have, I'm going to say, is equal to the maximum number of days we can have. For example, if our P's are equal to 1, 5, 9, 10, 15, then there's 5 P's, which means that there are 5 days, like 1, 4, 4, 1, and 5. Now, after we see that the number of P's equals the number of days, in order to maximize the number of days without satisfying the condition, we will need to select as many P's as possible. And for the ones like this first one, then we can select like this, the first, the middle, and last. Notice this will be the most optimal way of selecting them. And for this one, you can basically select any two that are not consecutive and like next to each other, and they'll be most optimal. And there's many different ways to do that. And it turns out you can choose a maximum of 34 before guaranteeing two that are adjacent, therefore guaranteeing that this condition is satisfied. So 35 is our answer. But if you want to be rigorous and prove this, we must also prove that it's possible to get 34 without satisfying the condition. And if it's not possible, then 35 isn't the minimum. So in order to prove that like 34 isn't guaranteeing that, we have to find one that goes against this. And we can find a certain pattern of P values that satisfy this condition, that there is no two consecutive ones on any list. And you can like do some subtraction and stuff, and you can get that our final sequence is 8 ones followed by 2 2s and a 10 and 2 2s. And then you repeat this again, which is 8 ones. And then you repeat this one again, and you can have 8 ones again. And you can check by yourself that in fact this does not satisfy the condition. You cannot find a number of consecutive days that do not that do sum to 13. So they've explained why 35-day guarantee now this condition being guaranteed. Is there any questions? Okay, so I'll take that as a no, and there's no questions. So this is clear, and like this method is clear, and there's like no confusion. So I think that there's no other solutions, and If you have like another solution, you can raise your hand right now. Okay, so I'll take that as a no, and for the final problem, I'll give it back to Yichen for it.
Okay, so for problem 4, does anyone like have any ideas even or like solutions they want to explain? Okay, I guess that's a no. So I'll just explain the whole thing. Okay, so now if you wanted to do this problem, you have to first know this inequality called the Cauchy-Schwarz inequality. Now, this inequality, like, we can have many terms, but for now, I'll just list out the two-term inequality. Now, it's basically this. So, yeah, all eyes on me, guys. Okay, so, um, if you have four like real numbers, like A, B, C, and D, um, then you have this A squared plus B squared.
Oh, Yichen, you need to press the key, like, you know, the eyes on yourself,
I
okay?
already pressed that, right?
Oh, okay. Yeah, because I didn't see you.
Yeah, I just pressed it. Okay. 23. Okay. Then you also have C squared plus D squared. Just a reminder, this is a two-term version. Like there's like you can have many terms. Then this is supposed to be, I think, greater than A B, wait, no, AC times 2. Where's the eraser? Oh my God. Oh yeah, it's AC plus BD squared. Please stop. Wait, okay, well, just do control. Okay. So now this proving this is not that bad. Like you can like just expand the whole thing, and then you get A squared C squared plus A squared D squared plus B squared C squared plus B squared D squared is greater than A squared C squared plus 2 ABCD plus B squared D squared. Okay, and now proving this, you can realize that these terms cancel out. And that leaves you with this and this. And that just simply complete the square. And then we get that in fact is true. Okay, now let's go back to the problem. Now, because so now we have absolute values here. And on the number line, we know that absolute value is just the distance between two numbers on the number line. For example, if this was x, this was y, then the absolute value of x minus y would simply be the distance between x and y. Okay, now because now we have 3 points. Now we have 3 points. So then that means that either that of the three x minus y absolute value y minus z, and absolute value z minus x, one of them must be the sum of the other two. Who wrote 172? That's not correct. Okay, so here then, for example, in this graph right here that I drew, xz would be equal to, or x minus z absolute value would be equal to x minus y absolute value plus y minus z absolute value. And then we can set variables or substitute x minus y's absolute value to be. Can people please stop typing random stuff and just putting it there? So we can substitute that to be a, which is like a equals, and then also substitute b equals y minus z, and then you would have a plus b equals x minus z absolute value. Okay, we want to choose which of x minus y y minus z and z minus x, we want to be a plus b. So because the coefficient, like an expression of z minus x absolute value is 49, and we want to maximize it, then it's logical to make the largest value have like the largest coefficient. So then we should probably just let z minus x absolute value equals a plus b. And now, because again, we want to maximize it, and then x, y, z are from the range 0 to 1369, then it's best to make this equal 1369. Because if it was any smaller, then obviously the expression would have a lower value. So we can just let that be 1369. And 1369 is, I believe, 37 squared. So okay, now we have the remaining expression of root 40a plus root 41b if we substitute it in these values. So then root 40a plus root 41b. Now, if we want to find the maximum value of this, then we would have to use the Cauchy-Schwarz inequality. Okay, so going back up to what we have over here, it's because we want to find the maximum value, we would want this expression to be on this side because then because if it was on that side, then we will be finding the minimum value and not maximum. So we want it to be on this side. And then the values for A, so then we can let oh, that's also A there. But let's let this be like A1 or something. A1 and B1. So then we can let A in this thing be root 40 and B in that thing be A1 or square root A1, and then C in that thing be square root 41 and D in that thing be square root B1. And if we just plug in those values, we get that 40 plus 41 times A1 plus B1. Um, that's greater than or equal to root 40a1 plus root 40 or root 41b1, and then whole thing squared. Okay, now we already know that this is 81, of course, and then we want to maximize it, so we let a1 plus b1 be 1369. Then that thing squared would be large or would be less than 81 times 1369. And as we mentioned earlier, this is 37 squared and that's 9 squared. So then that means the maximum value of, so then we get this root 40a1 plus root 41 b1 less than or equal to 9 times 37. And well, plugging back this into the original, we also have root 49 times 1369. Stop like selecting stuff, please. And then this would be 7 times 37. And then once we compute these out, we get our final answer of 592, which is the answer. Now, does anyone have any questions? I'll take that as a no.
Yichen, 7 times 37 does not equal 500.
No, like that thing plus that thing.
Yeah.
That plus that equals.
Okay.
I'm not sure how we just mentioned that that's 333. And then that's, oh, my math sucks. 259, I believe. Okay, and then just add them up to get that. Is that if no one has any comments or questions to say, I think that's the end of
Right.
our session today.
Yeah, I think that's the end. So there's no questions, right?
Okay. So thank you, Yichen and Edward. And later we will share the video and also the solution sheet with you guys in a couple of days. And also we'll send the scores to you guys in a couple of days. Okay. So let's call it a day. This is the end of the meeting. Okay. Thank you. Bye.